Hi all. Now let's see how we can conduct test of mean, population mean, single mean. Okay. Usually we will be taking the null hypothesis that our population mean equal to a value. That value will be given in the problem. So that value is mu naught. So we are taking the null hypothesis as h naught mu equal to mu naught, and we are testing this null hypothesis against any one of these alternatives. So we are testing a single null hypothesis against a single alternative hypothesis, and the single alternative hypothesis may be h1 mu not equal to mu naught, or this single alternative hypothesis may be h1 mu greater than mu naught, or this may be h1 mu less than mu naught. So we will be getting some hint regarding the alternative hypothesis in the question, but always remember that we will be taking the null hypothesis as h naught mu equal to mu naught. So null hypothesis will be taken as equal to, and after stating the null and alternative hypothesis, we will be selecting our level of significance. This also will be given in your problem. If it is not given in the problem, we will be taking this alpha as 5%, and the various test statistic we will be using while testing mean of the population. So based on the conditions that we are given, we will be choosing our test statistic. So we will be using any one of these test statistic based on these data given. So when our sample size is large, a sample size is said to be large when the number of sample observation is greater than 30. So when the sample size is large, definitely we will be using set test for testing population mean. Set test means normal test. So we will be referring standard normal tables. So when the sample size n is greater than 30 and sigma naught, and also when the sample size greater than 30 sigma unknown, definitely we will be using set test. Okay, so when sigma is known, this will be our test statistic x bar minus mu naught divided by sigma by root n, and this follows standard normal distribution. So the probability distribution of the test statistic here is standard normal distribution. And if the sample size n is large and also sigma unknown, then this sigma will be replaced by sample standard deviation s. Okay, so this is our test statistic then, x bar minus mu naught divided by s by root n. And next we are going to discuss the case when the sample size is less than 30. So when the sample size is less than 30 and sigma non, we will be going for set test again. Okay, so n is less than 30, that is for small samples. When the population standard deviation is known, again we will be using standard normal test, set test. So here test statistic is x bar minus mu naught divided by sigma by root n. And when n is less than 30 and sigma is unknown, we will be using t test, x bar minus mu naught divided by s by root n, and which follows t with the n minus 1 degrees of freedom. Degrees of freedom is the number of independent observations. Okay, so these are the test statistic usually we use in testing mean of population. So after deciding the test statistic, we have to decide our rejection region, critical region. So this rejection region is determined based on the alternative hypothesis. So if your alternative hypothesis is h1 mu not equal to mu naught and our test is set test, modulus z greater than or equal to z alpha by 2 will be our rejection region. And if mu greater than mu naught, our rejection region will be z greater than z alpha. So you can decide this by looking into your alternative hypothesis. And if alternative hypothesis is h1 mu less than mu naught, z less than minus z alpha will be your rejection region. This is the case of set test. And if we are conducting t test, then if h1 mu not equal to mu naught is your alternative hypothesis, then modulus t greater than or equal to t alpha by 2 will be your rejection region, and if h1 mu greater than mu naught, then t greater than t alpha will be your rejection region, and if h1 mu less than mu naught, then t less than minus t alpha will be your rejection region. And while conducting set test, the value of alpha usually will be taking as 1%, 2% or 5%. So you can refer to standard normal tables for finding the value of z alpha or z alpha by 2. Otherwise you can by heart these values so that you can directly apply that in the problem. That is when your level of significance is 1%, then if you are conducting a one tail test, that is if your alternative hypothesis is this 2 and your critical region is z greater than z alpha or z less than minus z alpha, then this will be your z alpha value for 1% level of significance. And if you are given 2%, then this will be the value of z alpha, and if you are given 5%, this will be your z alpha. And if you are having two tail test, the two tail test means your alternative hypothesis is not equal to and your critical region is modulus case, modulus z greater than or equal to z alpha by 2. So this is the two tail case, and these two are the one tail test. So if your rejection region is two tailed, that is modulus z greater than or equal to z alpha by 2, then z alpha by 2 will be your critical value, and for 1% it will be 2.58, for 2% it will be 2.326, and for 5% it will be 1.96. So after getting this z alpha or z alpha by 2 value, we will be comparing this with our calculated value of z or t. Okay, whatever be the test z or t, we will be comparing this critical value with our calculated z value. And if this critical region is true, that means if the value of z falls in exactly this region, we will be rejecting the null hypothesis, otherwise we will be accepting the null hypothesis.